Read the question. Yes, given some rough diagram that infinitesimally, the word is also there. Please try to. This is very important. Oh, yeah, this one. Okay, now both are hinged here. That also, he had explained everything the question, and this is telling theta, and this angle is 90 degrees. Let's get into the problem. The coefficient of friction between the two sticks is mu. Where that sticks here at this particular point. I think I'll take this blue color one. I'll take the blue color one. It'll be and draw the show all the forces. Don't go for torque one. First get the all the forces properly. Yeah, fine. So they are hinged here. Okay, let's get into the free body diagram showing forces. How that friction between the rods is something very strange here, no? So how the weight of the rod? So this weight of the rod. He didn't said anything, no. One stick leans on another. A right angle is formed where they meet. What about mass of the sticks? Can they be equal? M and M. I think look at the length. Look at the length here once. Carefully look at the length. This is A. This is B. This is O. Is it OA equal to OB? It's a right angle. It's a right angle is there here. Is it OA equal to OB? Nothing, no. So therefore the masses will be different. So this is M1G. This is M2G. So the center of mass of this will be here. Of this will be here. Then how to get the friction? This is the very interesting thing. Whose help we should take to get the friction? The equilibrium idea. The equilibrium idea has to be taken here, no? How to get the direction of friction? I'll show that the friction on this rod will be like this. The friction on this blue color rod will be in this direction. So on what basis? So let's go for torque. About B. weight M2G will set up anti-torque. Then how the normal contact will be acting in this direction. The normal contact here, I am unable to show it. I'll just put it here. So tell me, like, is it justified friction acting in this direction here? About point B, you go for torque. Due to rod, the weight of the rod, M2G will act in this direction. So anti-clockwise torque. Then any reaction here will intersect axis of rotation. This is the axis. Then normal contact here, this will intersect axis of rotation. Then who should set up, who should balance torque due to weight M2G? The friction only. So therefore the friction on the blue color rod should be like this. Able to make it out? This one. And normal contacts are why they are. Now let's come for talk about A. Due to weight M1G clockwise, friction will intersect axis of rotation. So the normal contact should be like this here. Just what you should do, sir, like how to manage such numericals. You have to get into draw diagram, show the forces, check yourself. Are you right or wrong? Verify it, analyze it. Not like directly you should make a, you should write the answer. Means you should write the answer. You should think right. This try to come out of this one. Okay, fine. We got all the forces here. So there'll be some reactions will be there. So let's not bother at A and B. The minimum angle theta for which sticks don't fall is 30 degrees. Theta only is given. The quotient of friction between two sticks is mu. The sticks have same linear mass density. From this, what we should bring? We should bring the find mu. What is unknown thing? Mu is the unknown thing. The friction between the sticks here. So let me take this is alpha, this angle. So alpha plus theta 90 degrees, first thing. Talk about A, I'll go for it. Talk about A, M1G, AO by 2 clockwise, AO by 2 cos theta. Shall I write directly? Or cos alpha. The distance is AO. So what can be this distance? AO by 2 cos alpha clockwise. Then talk normal reaction N AO equal to 0. Alpha is 90 minus theta. Solving this, I'll get N. N is equal to how much it is now? I'm directly writing it. M1G sine theta by 2. Substituting all. Alpha as 90 minus theta AO get eliminated. So they call this equation 1. And now similarly talk about B. Now what is the axis? Axis is horizontal axis. The axis is horizontal. Torque due to weight M2G BO by 2 sine theta. So sorry, cos theta it is. So this should be what happened anti-clockwise. Then we will balance that torque due to friction F into BO equal to 0. So solving this, I'll get F is equal to M2G cos theta by 2. Now what to do from here? Let's go for torque about O. Wall will set up torque. Only due to weight.
So there will be a reaction force due to hinge, no, sir?
Where from what?
Hinge, sir. Hinge A and hinge B.
Now you see that one stick leans on the action frame, a right angle is formed where they meet, and the right stick makes an angle theta. The left stick extends. The quotient of friction between two sticks. The sticks have same density. Then they are both hinged at the ground. Now, for the system to be equilibrium, tell me what I should assume here. The net force on for the rod system to be the net force acting on the rod along x must be zero, no? Able to understand? Here on this rod, some force will act here due to n horizontal component of n. So definitely here what happened, the reaction here should be such that net force should be zero, no? So therefore, what all these reactions are there, they'll set up equal and opposite torque. Otherwise, equilibrium of rod not possible. Equilibrium of that rod. So torque about tau will be only due to weight because F and N and the reactions will get nullified here. So therefore, this should be equal to M1G AO by 2 cos alpha should be equal to M2G OB by 2 cos theta. So alpha equal to 90 alpha, this will be cos alpha, this will be sin theta, it will become. So directly I'll write it, or M1 AO sin theta M2 AO or OA.
Sir.
No, M2 OB cos theta will come. So therefore M1 by M2 tan theta equal to M2 by M1 OB by OA. Anything can we say tan theta as it is a right angle triangle? Oh, sorry, right angle, sorry. This will be. So what is tan theta from the diagram? This should be equal to OA by OB. So OB by OB, so substituting this, tan theta equal to M2 by M1 by 1 by tan theta. I'll give equations number 3, this is 4, put 3 in 4. So therefore finally tan square theta equal to M2 by M1. Now what is use of this? So finally what we needed, F and for no slipping between the rods, what should be the friction? No, friction should be, I'll come to the this basic condition. Do we know F, S? Do we know N, S? And finally, when you substitute here, no, you'll get tan theta and M1, M2. Substituting this and solving, we'll get expression for mu.
Sir.
Ah.
Sir, since the weights of rods are different, won't the vertical component of reaction force be different, sir, for both the hinges?
For both the hinges,
Yes, sir. Vertical component, since weights of the rods are different, it will be different, right, sir?
no, for say like I'm talking about the torque here, no, say torque about O, the distance of O, you look at this horizontal, I don't know why you are not thinking this distance are different, no?
So that both distances will nullify them, sir?
Yeah, nullify them. In fact, always you do one thing, assume it and try it. What is there in that one?
Yes, sir. Sir, and what do we mean by that infinitesimally beyond that statement, sir?
English medium, English medium or Telugu medium? English medium or Telugu medium? English medium, infinitesimally, I think by this time you know calculus, you know mathematics. Just it is extended here. This length is very small. Elemental length, what will happen, will be there in contact. Mean the contact here, this one, this is infinitesimal. This you should not take this particular segment length should not be something L by 4, L by 3. That's the meaning of infinitesimally beyond the end of right stick.
Yes, sir.
Okay, solve for mu. It is given something 3 something. Check it that one. Let's take another one. Mu equal to 3 will come. Check it. Mu will be 3. I'll write the answer also. Okay, come for next one. Let me bring the idea of spring force here.
Sir,